Dear students, today's topic is wave function and how to derive it for a quantum mechanical particle. We know that particles in the atomic or subatomic domain like atoms, electrons, protons, alpha particles, they exhibit wave-like behavior under certain experimental conditions. And the wavelength associated with this type of particles is given by de Broglie relation as lambda is equal to h by p. H is Planck's constant and p is the momentum of the particle. Now, the kinetic energy of the particle is half mv square, where m is the mass and v is the particle velocity. And this is equal to the energy, and by Einstein relation, this is equal to h nu, where nu is the frequency of the wave associated with the particle. And we assume that the associated wave is traveling with a velocity v1, then h nu can be written as h v1 by lambda. And putting this lambda, we get h v1 divided by h into p divided by h into p, and this is equal to v1, and momentum p is equal to mv. So v1 is equal to half p. That is, the wave associated with the particle is moving with a velocity which is half of the particle velocity, that it is lagging behind the particle. This is highly impossible. To overcome this, we will consider the following steps. The differential form of any wave equation is given by double derivative of y with respect to x is equal to v square double derivative of y with respect to t, where v is the velocity of the wave. And the general solution of this equation is y is equal to a is amplitude, sine kx minus omega t, where k is the wave number and omega is the angular frequency. And k is related to wavelength lambda by this, and omega is 2 pi mu. And velocity v is equal to nu by lambda, and that is equal to omega by k. We consider two sinusoidal waves. One is y1 is equal to a sine kx minus omega t, and another one with a slightly different k and omega, but having the same amplitude, that is sine k plus dk x and omega plus d omega. If we superimpose these two, then the resultant wave y is equal to y1 plus y2, and by trigonometric relation, this is 2a cos dk by 2 x minus d omega by 2 t into sine k plus dk by 2 x minus omega plus d omega by 2 t. For cos we have to subtract this, and for sine we have to add this. And considering dk to be very small with respect to k, and similarly d omega with respect to omega, this we can write as 2a cos dk by 2x minus d omega by 2t into sine kx minus omega t. That is, we get back the original sine wave. Now the amplitude, this is the amplitude part. It is not only getting doubled, but it is varying with respect to time and x. That is, it is like a wave, and the wave velocity Vg is equal to d omega by dk. And this is of course the phase velocity, traveling with a phase velocity Vp is equal to omega by k. And graphically, this we can represent as this is like an envelope. This is a group traveling with group velocity Vg, and the waves inside it is traveling with phase velocity Vp. Now this wave function psi is formed as a group out of superposition of an infinite number of sinusoidal waves, and it is traveling with the group velocity which is equal to the particle velocity. But the wave function psi is complex. It is not a simple number, and we can write psi is equal to a e to the power minus I kx minus omega t. The psi has no physical meaning. It is a dimensionless quantity. But psi star psi, assuming psi as a function of x only, gives the probability density of finding the particle at x. Probability density. And if we integrate this over the entire range of x from minus infinity to plus infinity, this must be finite. So the characteristic of wave function is that it is smooth, it is continuous, single valued, there is no sharp increase or decrease, and it is square integrable, that is this integration is finite, so that we can find the particle. But for a quantum particle, there is always an uncertainty in measuring the position and momentum simultaneously. And Heisenberg uncertainty relation is this, that delta x into delta p is greater than and equal to h cross by 2, where delta x is given by x, that is, we take a number of measurements, this is the average value of those measurements, then subtract it from any measurement, taking the square, then we take the average again and take the square root. Similarly for delta p. Now we go ahead with this wave function. We know that k is equal to 2 pi by lambda. 2 pi by lambda, and lambda is equal to 2 pi by lambda is equal to h by p, or p is equal to h by 2 pi into k, that is h cross k. So p is related to k by this, and similarly omega is equal to 2 pi nu, that is 2 pi h nu divided by h, and by Einstein relation this is the energy, so 2 pi by h into E, or E is equal to h cross omega. We'll use this relation here. So we can write psi is equal to A e to the power I by h cross k x minus h cross E, and that is equal to A e to the power I by h cross, this is P x minus E t. This wave function psi is not a measurable quantity. It has no dimension. But all informations like the position, the momentum, the energy of the particle we can derive once we know the wave function psi. Now we take derivative of psi with respect to x. And this is equal to A I by h cross P e to the power I by h cross Px minus Et, and that is equal to I by h cross P psi. Or you can write P psi is equal to h cross by I del psi del t, or if we put a hat on this as if it is representing an operator, acting on psi is equal to minus h cross by, not minus, h cross by I, and taking psi out of the derivation, del t of psi. So this is the momentum operator, and in differentiation form, this is represents the momentum operator. So under stationary condition, this momentum operator acting on psi gives the momentum of the particle. Similarly, delta psi by delta t is equal to minus I by h cross E psi. So E operator is equal to minus h cross by I del t. Or here you can write that momentum operator is equal to h cross by I del t. This is energy operator, this is momentum operator. Now we will derive the wave equation. So we write it here. Psi is equal to A e to the power I by h cross Px minus Et we take the double derivative of psi with respect to x. So we get I by h cross p whole square psi. And single derivative of psi with respect to t, del psi by del t is equal to minus I by h cross e psi. This we can write as I by h cross whole square into p square, we write 2m into p square by 2m psi. And this is equal to I by h cross whole square into 2m, and this is the kinetic energy. And if the particle is free, that is not under any conservative field, then this is equal to total energy. So ultimately we get here E is equal to E psi is equal to minus h cross by I del psi del t. We put this value here. So I by h cross square into 2m into E psi is this minus h cross by I del psi. So we get this is h cross by I whole square. We are taking this to the left hand side, divided 1 by 2m into del double derivative of x psi with respect to x is equal to minus h cross by I del psi. Or we can write as minus IH cross del psi del t is equal to h cross square by 2m double derivative of psi with respect to x. I think it is all right. Positive, this becomes negative. Okay. So this is time independent. No, not time independent. This is time dependent Schrodinger equation. That is, psi changes with time in such a way that this portion is always equal to h cross by 2m double derivative of psi with respect to x. And this is actually Hamiltonian operator. This h cross square by 2m del x to x. So the time dependent Schrodinger equation is del psi by del t. That is, psi evolves with time in such a way that it is always equal to the multiplication of Hamiltonian with psi. Now the electron in a hydrogen atom is bound by the conservative electrostatic force. So we can expect standing waves. And for standing waves, the Schrodinger equation is time independent, and for that the total energy E is equal to kinetic energy plus potential energy. This kinetic energy is h cross square by 2m double derivative of, you use the operator, and potential energy is V, and this is equal to the total energy. So what will happen? H cross square by 2m into double derivative of x with respect to x plus V acting on psi is equal to V psi. This is time independent Schrodinger equation. This is time dependent Schrodinger equation. Okay, thank you.